Welcome to Yagya Group Design It Day, ABCs of RLCs and Power Distribution. Hello, my name is Jennifer Escobar and I am your host. Today we will show you some cool things you can do with KSIM. You may be wondering, what is KSIM? KSIM 3.0 offers you the ability to simulate your selected circuit component and see exactly how that particular component will behave and perform as part of your circuit design. This helps eliminate trial and error, thus significantly reducing time spent to test your newly designed circuit. You can even set your conditions such as ambient temperature, temperature rise, DC bias, and more. You can change the plot type to show impedance and ESR, current and voltage, capacitance and inductance, among many other plot types. You can simulate performance of KEMET capacitors and inductors, calculate capacitor aging, combine components, view spec sheets, download SPICE models, easily access data sheets, export images, and much more. Last but not least, with KSIM, you can save your simulation files to your computer and share them with your colleagues. To have the most optimal environment for everyone today, attendees will be muted during the demonstration. Now, without further ado, let me introduce our presenter today, Alan Cooper, Technical Sales Engineer at Yagya Group. Hello, Alan. Can you tell us a little bit about yourself?
Hello, everyone. Thank you for joining us today for the KSIM demo. I'm a senior electronics and electrical systems engineer with experience in vehicle systems. Let's start the demo. Okay, so the simplest way to start off to try and get to KEMET is to open a browser and go to KEMET's homepage, which is kemet.com. What you can actually see there is the screen that you're seeing in front of you. What we're going to talk about today is two things: the design tools, KSIM simulator, and also have a quick touch on some of the resources. The resources that you want as an engineer. You want to get to the components and you want to get to details and libraries and information, and that's all on this tab here. What I'll do is I'll actually go into Component Edge and briefly touch on that, go into KSIM, and then right at the end wrap up and show you a little bit about Engineering Center so you can get some more details about KSIM and how to use it and go and play with it. Okay, so let's start off by working through KSIM, and the easiest way to do that is to use a simple example. And the simple example we're going to use today is the design for a resonant capacitor. The resonant capacitor we're going to use here is a very simple version of it, and if you stay on for the presentation after this, I go through a power conversion that takes you through AC to DC and DC to DC conversion, bidirectional converter. It's far more complicated than this and in detail in terms of the components. And it does have an LLC resonant transformer in it. But here, just so we can touch on KSIM and just have a look at the details of KSIM, we're going to use a simple example. The resonant capacitor, as you see here, has got a switching network followed by an LLC, resonant tank with transfer into a rectifier. So what are the requirements for the resonant capacitor? First, let's have the mounting technology, through-hole technology or surface mount. Rated voltage 2000 volts, capacitance 33 nanofarads, or what will ever produce the right amount of energy that we need. Rated tolerance 5%, ambient temperature 75%, operating current 18 amps RMS at 125 kilohertz. That's 18 amps at 125 kilohertz, 75 degrees C. Lowest possible, i.e. single component, if we can make it with a single component, which we always try and do first off. But if not, the dimensions that we've got to fit it into is 50 by 17 by 50, and we can actually use multiple components. So let's actually go into the resources and touch on Component Edge, so we can actually go and have a look at the components with some of those. That wasn't nice to me. Why did it do that? There we go. Okay, so now we have Component Edge. Well, obviously the internet's playing a little not friendly today, but there we go. It does that now and again. Okay, so what we've actually got here in Component Edge, you've got all the components that you ever wanted, and if you want to go and browse through these and look at them in detail, you can do. But what I actually want to do is show you a couple of things that actually can get you some quick searches and quick to the components that you're looking for. The one that I tend to like is the visual search. And what this does is it allows me to actually use my cursor to go and find, if you like, the voltage and capacitance of what I want. It has the various technologies. I can actually switch them on, switch them off if I want to, and go and search for the particular versions that I want to look for, or components that I actually want to look for. But anyway, that's the visual way of doing it. Let's do another way. There's another powerful way of actually doing it, and that is to use the actual component, the component parameters that you need. As you can see, I've been playing around with this already, especially for this particular design. So we're going to have a look at the 2000 volts, 33 nanofarads, 5%. Let's see what that does. And there we go. It basically gone and selected either the ceramic or film dielectrics for us in terms of what we were looking for. I'm not going to go through this in great detail because you can actually go and do some more searching. I just want to show you down the left-hand side the various parameters, pull downs that you can actually go and click and select and actually go and hone down your design, hone down the particular component that you're looking for. But I want to go into KSIM in a second and just show you exactly what it is. But just to note that what we've got here is we've got the various filters. We've got the 5%, 2000 volts, and the 33 nanofarads. So that's basically just a quick touch on component edge. All right, so let's go back to the home page. There are various ways to get to KSIM, but this I think is the simplest way and an easy way to get what we need to do. So here's KSIM. Doesn't look like a lot at the moment, but that's because we haven't really got into it. Down the left-hand side on the left panel, you've got the capacitor simulation, capacitor from power, ceramic aging tool, film lifetime, inductor simulation tools. So we're going to have a look at the capacitor simulation. So here we have there we go. Let's get rid of that out of the way. And we're actually going to look at I'm going to have a look at the film. Well, we had a choice of two, ceramic or film. I'm going to look at film first. Not for any particular reason, but the film one. As you can see, I got pull downs. I'm actually going to go and look at an R75. The reason I looked at an R75 is because it's one of those components that KEMET is specifically designed for snubbers, for resonant capacitors, and for DC links. So that's where I would tend to start with looking at information or looking at analysis to actually find a solution for this particular problem. There are other in the series. If I would need to tweak it up for higher temperature, I'd take the R75H. Then if I need to do higher DVDT, I'd look at R76. But let's just look at this one for the moment. All right, so we're looking at the voltage rating. Let's take the voltage rating, 2000 volts. There we go. Let's select the 33 nanofarad component. And what we have here is what looks like an output picture, which is great. Therefore, we can do some analysis. Let me wander around the screen for you and show you exactly what's available. First and foremost, there's a chart type. There's basic chart types that are available for the analysis. Capacitance, inductance, current and voltage we look at in a minute. The S1, the S2 parameters are available, and you can actually output those. There's a SPICE model. There's a SPICE model which I want to talk about a little more in detail because it's not actually SPICE. We output SPICE models. We don't actually simulate SPICE models as per se. You've got the current versus V bias, and then we're also going to look at the temporize and ripple current. There's a couple of other graphs in there that you can actually look at. We won't necessarily focus on those today. We're just going to walk through most of the what have you, so you can actually see it, and you can go back and play with these at a later stage. So let's move on. What you've actually got here is a cursor that can actually swing down and wander across the the graph, and will actually pick off at the various points the information that are actually on the graph. So you don't have to go out and get your ruler and try and figure out what's what and draw cursors and draw horizontal and vertical lines. You actually got a cursor with the actual information there. And if you actually look at you do a right click on it, you can save the image or copy the image of the actual cursor there. Okay, so the other thing I can quickly just show you is, well, we won't do it there, we'll do it on the next one. Let's look at the information bar. So we have an information bar at the moment that basically shows me the component. Let's have a quick notice that you may not notice that you can actually use that caret and turn the caret down. I've got a basic spec information about the component. Can I get more? Absolutely. I can get the detail of it, more of the detail of it there. And if I want to go bury myself into the spec sheet and the data sheet, and therefore have access to it from the simulation environment, I just click on this particular point. And what that does is it takes me into, well, actually the internet is behaving reasonably well. Takes me into an environment where I can actually find the spec sheet, the data sheet, and go into those, and even to the step and CAD models if I actually need them. And therefore I can actually get to the detail of a particular component at my fingertips and from the simulator. Okay, so let's go back into the simulation and have a look at the information bar again. Okay, so let's wander to the right. There's the part number. There's the information in terms of the cap, the voltage, the dielectric, the quantity. I can add more capacitance in there if I need to, and I can use the tool with 1s, 2s, 3s, 4s, whatever I need to do in terms of how much of an array I want to build. And also I actually have the ability to put the voltage bias on it, and also to put on the ambient temperature. So let's wander down to another graph so we can actually see what else is going on in here. Okay, so we have current and voltage. As you can see from this, the current graph basically rises up and goes across and down, and the voltage graph comes across and voltage comes down. Now, if you stay around for the presentation after this, you will see this graph several times. It's about helping you to design the component with regards to ripple current and ripple voltage. The voltage, the graph that you will see there, that's actually it's slightly prettier than this one, and it's very nice and neat and straight, and it's not actually a real in terms of real. It's real enough. But what it actually describes to you on the left-hand side, where the voltage is the voltage area, which is colored in yellow, and on the right-hand side is the current area in terms of the limitations of what the component do in terms of ripple, and that's colored in green. And so when you're actually considering those things, this is the type of graph that you can actually find in KSIM that can help you out to know what's going on. So let's have another look at a couple of the features that are available here. What I can actually do is I can actually switch on and switch off a particular graph in terms of the current or the voltage. I can do the switching on and switching off of that. If I actually want to, what I'm really concerned about is what's the ripple current going to be around 125 kilohertz. So I can actually go and try and work out what's going on round and down here and look at that. Or I can actually go and take hold of the graph and just zoom in by just selecting across, and therefore I can actually expand it and see what's going on a lot easier. And therefore I'm down to about 125 kilohertz there. It looks like the current, if you look at the current, is about 5 amps. Well, what that's going to say to me is that I'm going to be concerned that this single component is not going to be able to provide me with my 18. So I should be looking at maybe 3, 4 or 5 of these particular components in an array, so that I can actually get the correct current that I actually want. So that's one way of doing. That's a way of actually looking at the detail on the thing. I can reset, so I can go back to the graph, and it's very quick and very easy to do in terms of looking at the detail, and so I can do the analysis. As you can see, what I'm going to talk about at the bottom now is the export. Or in fact, the first and the last, the export, the CSV. CSV, as you possibly know, is a common separated value list. And what that basically does is that the values, the actual values that are available on this particular graph can be exported into a CSV file, which is essentially Excel, an Excel file that you can actually save, keep, and distribute, as Jennifer indicated earlier. Also, if you want to export the image or a picture of it, so you've got all the information on a picture, go to the right-hand end. You can actually download an image of the actual graph that I've actually got there. The next thing we'll look at, let's go down there. We talked about the S1 and S2 parameters. I'll talk about the other one. There's an S2P download there. What that does is it basically downloads the S parameter model, if you're familiar with those, and what they will do for you. That's also available. It's a common standard these days in the industry. So if you need those models and you work with them, you can actually get that as well. Let's just have a look at the SPICE model. Okay, so what the SPICE model is actually telling you is really not the SPICE model per se. The SPICE model is something that you can actually dump and download. What this is showing you is the actual model that's available in terms of the simulator. Because KEMET actually manufactures these components and designs them, and is one of the leading edge suppliers for these particular devices, they actually measure them. But the measurements that are actually obtained from them are used to do this simulation. So the model that you're actually representing here isn't a SPICE model, which is a simulated model and a theoretical model. This is actually a real model and with real values. So they're actually, the values are, if you like, real with extrapolation. So the whole point of what you actually got is then what you're measuring and what you're looking at is a real value model, and can give you real data as opposed to theoretical simulated data. Okay, so let's go on a little further and have a look at the, there we go, to the temporized and ripple current. What this actually will provide you with is information with regards to temperature rise versus ripple current. As you can see, the temperature rise is split into three sectors, three colored sectors. My screen, it's green, orange, and sort of pink. Maybe nice if it went a little redder, but that's okay. The green area goes from 0 to 25 degrees C, and the orange is 25 to 50, and then the 60. So what you've also got across the top here is you've got various frequency points. We're interested in 125,000 or 125K. I can actually put that into, oops, didn't want to do that, but whatever. There we go. Thank you. Goes back to 125. So I can actually change the frequency of what we get. And then I can actually have a look down here. And as we saw before, this particular component will need 4 or 5 components to actually provide us with the 18 amps that we're really trying to find. What we can also do on this particular graph is actually knock out the frequencies. So if I want to look at a particular set of them, I can actually, if I do the right thing and not actually zoom in on it, I can actually get the current versus the temperature rise, and with all the other information that's in there at the moment. So let's move on to using the having a look at the ceramic capability. Let's open another KSIM and go back to one of my favorite component dielectrics for resonant snubbers, for resonant capacitors, snubbers, and DC links. For this particular, the size that we were looking, the size that we're looking for is the 3640s. and the 3640 has a 2000 has the 2000 volts in there. We can actually have a look at the it says 15 nanofarads, so perhaps it's 15 nanofarad. We're going to have to use at least two to get to 33 nanofarads, but to see what actually that produces. Okay, so let's go through that. Let's go and have a look at the current and voltage graph. What we've actually got here, around the 125 arena. Let's go down here, 125. We're looking at about 8.78 amps. So really, probably two of them will actually do it, because you're looking at 2 9s are 18. So it's potentially the right sort of graph. We can do that. We can put the 2 in there, and that will actually give us the values that we're actually looking for, and we can actually go and look at that. So our current 125, we're looking, it says 14-ish, but I think you'll find that it's actually going to be higher than that. Maybe I'm getting my let's do this. I know what I need to do here is put on the ambient temperature in terms of what that, and that should actually give us the right sort of currents that we're looking for. So let's go one stage further, and let's have a look at the temperature rise over ripple in terms of where we are with that one. And as you see, the information that I actually put in the information bar has actually traveled through to the other graphs. I've got to go back and actually have a look at the 125 frequency, and let's have a look and see what that produces for us. 125, we're looking in the at the 125 hertz. All right, let's do it the right way. We're actually to see if we can actually do this. Our 18 amps is round about there, and that will actually come out and give us the correct current. And we're actually in the green region in terms of what we're doing. So we're actually well within the safe limit in terms of being a 25-degree rise over ambient. If we were in the orange area, we'd have to actually consider is it safe enough to do that, and have a significant look at the design, either the requirements or our design itself. If it actually went up into the red environment, I would suggest that the design is potentially not effective in terms of meeting the requirements. The requirements need to change. So what we've actually done is we've actually gone through. I've gone through the KSIM with regards to this particular design, and gone through an analysis and looked at the tool and looked at the various aspects of it, from the point of ripple current, rise over ambient, in terms of the ripple capability. What I like to do now is to actually go into, I'm going to show you where I got it before, and that is the engineering center. I have this, in fact, let's do it for real in terms of going this way, and opening up the tab in terms of engineering center, because the internet is playing nice at the moment. So this is what you'd see if you went into the engineering center. And as you go through the engineering center, you can see the products, applications, resources in terms of what you've actually seen on the pull downs. I can go a bit further down into the design tools and the app notes and blogs. And if I click on the design tools, what it actually gives you is the set of design tools that were actually available in KSIM. There are other tools that are available that are not in KSIM, and what the reason for that is that we want to get the tools available to our customers quickly and simply, because the integration process does take time and verification of putting it into software, so we don't actually cause problems and issues when we put it into the KSIM environment. So there are a couple of tools that are outside of them, outside of it, KLM is in there, the inductive core losses in KSIM, the aging calculators in there. The aluminium, this one isn't, and the fit isn't, and that's because they're used externally and can actually be moved into KSIM at a later point. But however, what I also want to point out to you is that what's also available in KSIM are these pre-built projects, so you can actually go and experiment yourself in terms of looking at particular examples other than the one that I've taken you through, and actually get yourself familiar with it and use it and become more detailed with it and find it a helpful and useful tool, and also the engineering center as well. So at that point, I would like to end the demonstration for today.